Hi everyone, welcome to the last video for R for this week and for the entire quarter. It's not going to be a very long video. This covers chapter 7 in the manual. I would really suggest reading over the little introduction, couple of paragraphs in chapter 7, just to kind of get a sense of why we're doing this and like the motivation for this section. I'm not going to cover it because I want this video to be a little shorter. I apologize for the really long videos in this module. But yeah, so what we're going to cover today is just a little bit of linear regression. And I know that a lot of you don't have any stats background and might not even know what a linear regression is. But it's basically a model that allows you to see how much one variable explains another variable, or really how much one is correlated with another one, and kind of how the two variables move together. Right, so we're not going to go super deep into anything, but we have covered it in the Excel section. So I wanted to show you how to do the same thing in R. It's really simple. So yeah, let's get into it. Just a reminder, the data frame that I'm using is going to be attached right along with this video. So you can definitely download it and follow along as well. So first I want to actually upload my data. Here I have to name my object first. So this is going to be the data frame that I'm importing. So I've named it T_E, and that's just short for TVElect, which is the name of the file. Then I'm doing my assignment operator. So this object is going to get read.csv. Please remember that that command. That's how you read in your CSV. Again, remember from the last video, you can go to import dataset and do it that way through some drop-down menus if you feel more comfortable. But here, I'm going to remind you how to type it in to find it. So once we have our quotations here, open quotations, or empty quotations, I should say, we're going to type, and I should say parentheses, sorry, read.csv, our empty parentheses, then we're going to type quotations. That's really important for it to know that it's going to be a path name. If you don't type those quotations, this will not work. And then I'm just going to press tab. It'll come up with this menu for me so I can walk through my working directory and find the file that I want. So I know that my file is in lab documents, so I'm going to select that one and press enter. I'm going to press tab again, and then I'm going to go down to lab 10, press enter. I'm going to press tab again, and mine is in my lab 10 3 folder. That's where the document is that I want. You would, of course, pick the path for your local computer or your local device that contains this file with the data in it. So our paths are not going to be the same. Okay. I mean, technically they could be if you set it up this way. Anyway, so here we have lab documents, lab 10, lab 10 3, and then I need to select my file finally. So tab one more time, and you can see I have agelang and TVElect. I'm going to choose the TVElect file, and that's all I have to do. Now I can press Control Enter, and it uploads it for me really quick because this is a very big data frame. But here we can see we just have two variables, hours TV, elect bill, so obviously the number of hours someone watches TV, and the electric bill amount. And if we scroll down, we can see all of our data. This also gives us some summary, so showing 240 to 250 of 250 entries, and there are 2 columns. Our entries are our rows, so that lets you know how many rows there are and how many columns there are. Okay, so I'm going to close that out. I don't need it anymore. And before I show you what the command is, let's take a look at it with our question mark and what the command is that I want to know more about. So LM is the command for your linear regression. So I want to know a little bit more about it before I run it. So I'm going to press Control Enter on our question mark LM, and I'll pull up the help page for it. So what does it do? It fits linear models. It'll say in the description, it's used to fit linear models, carry out regression, single stratum analysis of variance, and analysis of covariance. You don't really need to worry about those. You just need to know that it carries out regressions because that's what we're doing. So then you can look at how you have to fill it in. So you can see LM takes a formula. You can have data, subset, weights, what you're going to do with your NAs. You can set up a different method if you want. Anyway, so some different things. We're not going to care about too many of them, but here we can see for formula, an object of class formula, and I'm going to show you how to write that. And for data, I just wanted to point out that this says an optional data frame, list, or environment, or object coercible by as.data.frame to a data frame. This kind of lets us know that the form that our data needs to be in is a data frame. Luckily for us, ours already was read in as a data frame, but if you were doing this on your own and you had your data in the form of like a matrix or something, you'd want to convert it to a data frame first. Okay, so moving on, we can actually run this now. And the way we run it is we name our object like usual. So this is going to be an object that saves our model. You don't need to have this object here, but if you run your model and don't save it to an object, well, you're not going to be able to then pull out information from it afterwards. So I would recommend saving it to an object. We're going to call this object linear. We're going to do our assignment operator like usual, and then LM with our parentheses. And then here, we're going to select from our data frame the variables we want, and we're going to write it in a formula format. So the first one, we do TE, so we're naming our data frame, then we're doing $ to select the column we want, and then we're doing electric bill. So if I want to type this out myself, I would do T_E. Here, it highlights it, so I can press enter, $, and then it gives me my option. So I want to do electric bill. Then we're doing this squiggly, and so this little tilde is what makes it a formula. So all it is that this, what we're writing is that this variable is then going to be explained by this variable. So this has to be our dependent variable first for the LM function. The dependent variable goes first. If you're like, I don't know what a dependent variable is, please go read over Chapter 7. It's very short. It's like 3 pages, but it will explain more in depth what a dependent variable is. Basically, it's the variable that is changing based on our independent variable. So this is our dependent variable, and then this is our independent variable. So we have TE, $, and now we've selected hours TV. So independent variable are the hours because those just kind of vary on their own. We think, though, or one might hypothesize, that the electric bill is going to be affected by the number of hours somebody watches TV, right? Your TV uses electricity. The more you watch it, the more electricity you use, the higher your electric bill will be. So I think that my electric bill is going to be dependent on my hours of TV that I watch. So that's why this is the dependent variable, this is the independent variable, and just remember to put the tilde in between those. Okay, if I run this, I can see that it runs it like any object assignment code, so it doesn't show me an output. So first, to see what I ran, you can see that the class of this object is unlike the ones we've seen before. The class of it is LM. So it is particular to the model that we're running. Okay, so moving on to example 7.2.1, we're just going to see what did that get us. If we type out linear and run it, you can see that it gives us what our linear model is. So our linear model, it tells you what the formula was that you called, which was your TV elect bill as a function of your hours of TV. And then it shows you these 2 coefficients. So these are important to know what they are. Your intercept is essentially the base level of electric bill if this variable equals 0. So for somebody who watches no TV, we would expect their electric bill to be about 1.538. Then, for every hour of TV someone watches, we would expect the electric bill to increase on average by 3.002. So here we have the intercept, and we have our coefficient for our one covariate. You're not going to be super quizzed on like the terms for it, but you do need to know how to read the output. And if you're asked what is the intercept for this, you need to be able to write it out. Or if you're asked what is the coefficient for your variable blank, you need to also be able to give me the answer of like 3.02. Okay, so moving on, we want to know how correlated these two variables are, right? So we can come up with a model. You can run this on basically anything and it will spit out a model to you, but it might not be appropriate if our variables aren't actually highly correlated. So if we want to know how correlated our variables are, we're going to run core, and then you put your two variables separated by a comma. It doesn't matter the order that you put them in. So this is exactly the same as writing out core TV, TE hours TV, comma, TE elect bill. The order doesn't matter. It will be the same either way. So we're going to press enter on this, and we can see that it's 0.998. So correlation, your value for that, it ranges in between -1 and 1. So the negative or positive sign tells you the direction of the correlation, meaning that if it's negative, as one variable increases, your other variable decreases. Whereas if it's positive, as one variable increases, your other variable increases. So for this one, as our TV hours increase, our electric bill increases. That's why it's a positive number. Then the value of it tells you how strong the correlation is. Between anything below like 0.3 is usually a pretty weak or like no correlation. We don't think of that as anything but maybe potential just noise. Between 0.3 and 0.5 is weak correlation, and these are just general cutoffs that people use. They're not super strict. Anything between 0.5 and 0.7 means there's moderate correlation. And then anything above 0.7 means there's high correlation. So we can see with a value of 0.998, knowing that we're bounded at 1, these two variables are super highly correlated. So that tells us that running a linear model on these running a model on these that measures correlation is a good thing to do, or would be at least, intelligible to do. Okay. So we had r squared in Excel, and if we want to get our r squared value, we can do one of two things. R squared is simply the correlation number squared, so we can just run core exactly as we did it before, and then just do caret 2, so it's just our correlation value squared. We can see that that is 0.997, or we can get it from our summary. So if we do summary, and then our model object, we will get all of this. So it shows you again the formula that you ran. This is what your model is. It gives you your residuals. It gives you your coefficients. So this also shows you, again, the intercept. You get that same value of 1.537. It gives you your coefficient for TV hours, hours TV, which is, again, 3.00 rounded to 2. It'll give you the standard error for each variable. And remember our p-values from SPSS? Well, this actually gives you the same p-values where you can see whether or not these variables are significantly correlated with your independent variable. So are these effects significant? Meaning, are they actually significantly different than 0? Okay, aside from all that, the r squared, we can get it down here in this line. It says multiple r squared, we have 0.997. That is the same number we had up here when we just did our correlation squared. So you can get it either way if you're asked to get it. It doesn't matter which way you do. Okay, so that's all for linear regressions really. And then we're just gonna go over one more plot and then we'll be done. So how do we make a scatter plot? It's very simple. We just do plot, and then we're gonna do our two variables. So plot, Here we're doing hours TV and then electric bill. This actually does matter for the order. You need to put your X variable, so the variable that's being measured on your x-axis, that one needs to go first. And the variable that's measured on your x-axis is always going to be your independent variable. Then your dependent variable goes on the y-axis and comes second. So we do plot independent variable, comma, dependent variable, comma, any other options we want to set. So here we are setting our x-axis label to be hours watching TV a week. Our y-axis label is going to be electricity bill cost. And then our main, remember, that's how we indicate our title. Our title of our graph is going to be regression between TV watching and electricity bill. And that's all for our plot. We're going to do this as its own code, and then separately, if we want to put a linear regression line over our data, so we did this actually in Excel as well. All we have to do is run the command after our plot command. So first we run a command for plotting, and then we run right after it the command AB line, and then in parentheses linear, and then we're choosing our color or COL to equal red in quotations. So let's run that. That's our plot. Let's put a line over it. And there you can see, let me zoom in. This is what we get. So you can see from the data points alone, they are super correlated with each other. But you can also then see with the line overlaid on it, it goes right through almost all of our points. So that's why our correlation is so high. And yeah, that's how you get a nice scatter plot. There's obviously other options you can put into plot, like a ton of them. So if you ever want to look any of those up, feel free. And your color doesn't have to be red. We could change it to like blue or something like that. But just remember for this, you plot first and then you add AB line as a separate line of code right after you plot it. Okay, that is all for R, that is all for Chapter 7, and that is all for this class. Thank you so much for watching. I know it was a lot of information. I will try to make the test as intuitive and simple as I can. But yeah, please review the chapters in the manual, review and work along with the videos, like try to do it yourself. I am going to post the code, but I really do encourage actually typing out the code with the videos, because honestly, it's something that if you're not used to, I find that the easiest way to build confidence in it and build the ability of it is to actually type it yourself and not just copy and paste somebody else's code. So please work along with that. And then just a reminder, I sent out an announcement. There are 3 separate office hours I am holding this week to try to give people help with all of the R questions they have, as well as paper questions and stuff like that. So yeah, hope to see you, hope to hear from you, and good luck with learning R.